All right, folks, so in this video, we're going to talk about process equipment. And what this means is that in the other videos, I've given you an overview. There were multiple different steps on the manufacturing line. We went through those steps. We talked about each one of them individually. So this is kind of what I'm referring to. Down at the bottom, we talked about a bioreactor or a fermenter, the harvest, the recovery, the purification, the formulation. We skipped the sterilization part. We went to fill finish, and we skipped the freeze-drying part. So what we need to do now that you have a broader picture, now that you have this overview of what's happening on the inside of a company, we need to now take a little bit more time and discuss more details of certain steps along the way. And that's what section 5.4 is going to be about in your textbook that you've got. So the process equipment section is going to start here. And one of the very first things, as you can imagine, that they are going to discuss is good old faithful. And that good old faithful is our bioreactor or our fermenter. So we need to go back and we need to talk a little bit about more details that go on inside of this contraption that could be way bigger than me in a manufacturing line or a production line. So every facility needs certain pieces of equipment, right? That's what this chapter is all about. It's about equipment and it's about utilities. So we need to talk about the equipment. And this equipment, yes, it is fermenters and it is bioreactors, but you know what? It's way more than that, because the facility also needs equipment that will store the materials until we're ready for them, and then process materials. So that would be as I'm needing and as I'm using them, we are making things, and then equipment that moves it from one step to the next. All of that is equipment, right? All of that are moving parts of the puzzle in the biomanufacturing arena. So with the pieces of equipment, what you're seeing over here in the side of the right-hand side are just examples. That's all that it is. It looks like I get a big old maniac mansion bioreactor right there, and then I am putting stuff in it, and then we're taking stuff out through the help of pumps, and we're cleaning it up with some filters, and then we're putting it into another container or a contraption, and then we eventually go through and start filling up little containers. Okay, all of that is equipment. I know that, but we need to talk about details now. That's what this is all about. The problem, oh no, is that some of the equipment is proprietary. So we don't really even know the little ins and outs of some of this equipment because these companies are going to keep it a secret. So what this means is that we can discuss at least the general types of things that you're going to find. But as far as like nitpicking details and being like, this is the way it's going to be every single time, the answer is no, it's not. Sorry. So move on, because different companies will have their own ways of doing things. But there is a general trend here, and we could talk about some of these general trends. We're going to have instrumentation or equipment that can handle liquids, gases, and solids. So all of those are going to be out there because it really just depends on what I'm using, what am I making, what are we trying to end up with, and there is an option out there for all of those manufacturing types of companies. So am I making a liquid, and that liquid is going to go into a little tiny vial that's going to be capped? If so, there's instrumentation for that. Am I trying to recover a solid product and clean that solid product up? Because if so, there's going to be instrumentation for that. So either way, the company is going to have what the company wants. And there is a chance that this piece of instrumentation or this piece of equipment will be modified in order to fit the specific needs for the company that you're working for. We also need some tanks, of course, some tanks to store some stuff. We need some piping, because that piping is going to help us carry these big bulk volume solutions from one place to the next. Well, okay, that needs a little bit of help. So we're going to have some pumps, and the pump's job is to move that liquid from one spot to the next. And then, of course, we're going to have some valves. And the valves are going to direct the flow. So it allows me to turn off, turn on. Think about the valves of your water pipes at home up underneath your sinks. So you're going to turn them on, you're going to turn them off, and then you can divert the flow from one area to the next, being like Super Mario. And, just go through the plumber idea and be able to transfer that liquid from one spot to the next. That's what this is all about. So tanks are going to be common. Piping is going to be common. Pumps move the stuff through, and valves direct the flow. The issue here is that, this is sciencey type of stuff. And sciencey types of stuff can actually interfere and react with some of the material. So we've got to make sure that what we are using in a laboratory environment or what we're using in a manufacturing environment is going to be very friendly to the materials that those particular tanks or piping or pumps or valves are made out of, because we don't want them to react with that stuff. Because if they start to react, then they start to corrode and they start to rust and they start to fall apart. And before you know it, boom, in the manufacturing world we go. So for that reason, stainless steel is actually going to be one of the most common, but there are different choices out there. We'll talk about those choices in just a second. Next up, these pieces have to stay sterile and aseptic. Aseptic basically means the process of making sure it's just completely clean and that it stays clean. And sterile, of course, is the idea that there's no germ, there's no interference, there's no contaminant at all, period, on the types of material and the things that I am using in the manufacturing line. So everything has to stay super clean. I want you to think of a surgery room, right? That's sterile and aseptic. Aseptic processes take place, and that creates a sterile environment for us to work in, because we want to cut you open and we want to pull your knee apart and we want to tie your ligaments back together into a tiny little knot, and then we're going to sew you back up. Okay, so if that is the case, then I don't want to do that in a dirty, filthy, nasty alleyway. I want to do that in a clean, sterile environment. And biomanufacturing and bioprocessing is going to be the same way. So these tanks, and you're seeing a tank here in the picture, of course, over on the right-hand side. These tanks are very commonly made out of stainless steel. The stainless steel is not the only option, though. You have different types of materials that are out there depending on what you're using. So fiberglass, reinforced plastic, polypropylene, glass, aluminum, any material will be okay as long as it suits the needs for that particular company and that particular manufacturing process. So stainless steel is not the only choice that we have. There are multiple different options, but that really depends on what you're making and who company that you're working for. Storing and mixing tanks, they do try to reuse them, and we call them fixed or we call them mobile. So fixed just means, of course, they're stationary. They're going to stay put. You're not going to be able to move the tank. And then mobile, of course, are on wheels. Okay, so that way, when it does what it needs to do or whatever the case is, I can scoot it from one area of the facility to the next. So reusable is a very good option, because once I drain or once I dump or once I use the stuff that's in that holding tank, then I can just make sure that it's clean before I go back and do it all over again. So that's less money that a company has to invest into equipment, because it is more than one-time use. However, cleaning it takes time. We're going to have to make sure that it is super clean, aseptic, sterile, blah, 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 blah. And sometimes we just don't have time for that. Sometimes it takes too much effort for that, and it holds the production up. So when the production gets held up, the money gets held up, because that means no more product is being made. So disposable technology is also something that can come into the picture. So disposable basically means just that. You dispose of it. So you have a tank, maybe like the one in the picture or look similar to the one in the picture, and you have some type of culture that maybe be growing in it, or some type of organism that's going to do something for you, or some types of cell. And then once that is ready, and once that is transferred, once that is used, I clean my hands. Only thing I got to do is throw that into the dump. Well, as you can imagine, these maybe aren't the best case scenarios for all manufacturing lines or all companies, basically due to the types of material that's got to be used in order to manufacture and make these tanks. So I'll talk about this in a minute, and I'll show you a picture of them. But fixed and mobile are perfectly okay options, and disposable is out there as well for those people that can use it. As far as tanks go, tanks can also be above ground or below ground. Yeah, that means above ground means you can see them with your eyeballs, or below ground means that they're buried, and they're going to be stationary because of that reason. They're going to be fixed tanks, but either one of these are going to be okay depending on what the company does. They come in all shapes and sizes, so these fermenters, these bioreactors, blah, 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 holding tanks, whatever the case is. You have options, of course, right? And those options can be conical shaped or sphere shaped. They can go horizontal. They can go vertical, cylinder wise. They can be what we call open and closed. So in opened, I want you to think of like a stock pot on your countertop or on your stove top. So it is a stock pot that you are making maybe chicken noodle soup in because it's a cold winter and that's what you're doing. So that is open, right? You can take the lid off and you can get and have access to the inside. You can stir it, you can smell it, you can taste test it, you can do whatever you want to do without an issue at all. But there is a closed option as well, and the closed option means there is no lid that you can open up and get to on the inside. It's made in a different way, and I'll show you a picture of those in just a minute. Many tanks are what we call pressurized. So here I want you to think of a pressure cooker. So again, if you're in your kitchen and you are pressure cooking something because, you know, that's how your granny did it. And hey, I'm not knocking it. I've got my own pressure cooker. I still use it. It works great. If you've never had a pressure cooker, I highly encourage it. But what happens is that you completely seal the lid off and you put this thing under heat, right? So heat is often going to be something that is needed for this process to take place. And that heat, of course, under a closed system is going to create some very, very high pressure systems and situations for us. So we've got to handle that with proper care. So like a pressure cooker, you want to handle it carefully. You want to let it cool down. You want to release the pressure, release the steam, and that way you can safely open up the valves and then transfer things from one spot to the next. So again, these types of tanks, these options are going to be chosen not by you, but by the engineers or by the CEOs of the companies, because they have an insight of maybe how that production should be made or how it should be handled. So these decisions are going to be made by someone else. We just need to be able to use them the proper way and know that there are differences that are out there, of course. The disposable tech that we're talking about, Millipore is probably one of the most widely known disposable tanks that are out there. They have a Millipore Mobius, and Marvel fans, there you go, it's Mobius. So the Millipore Mobius mixing systems are meant to be disposable, and they are becoming more and more common. And what I like to refer to these as, because I keep referring to things as the kitchen, because you're in the kitchen, that's a very familiar space for you, but I like to talk about these as crock pot bags. So crock pots, yeah, you burn low and slow, right? You put a chunk of meat in there, you put a lid on it, and you just let it cook all day long. Well, you know, for some of us, we don't use any bags, and we open up the lid and we take everything out and we clean it and we wash it. Sometimes stuff gets gunked up on the inside. It takes a lot of effort to clean them. They're quite heavy, and some of us just don't want to do that. So instead, what happens is they put a plastic bag on the inside, crock pot bags. So the bag is safe to cook in. You put your stuff that you need to cook you put the lid on, everything's okay. After the cooking process is done, you take the lid off, you take everything out, and then you've got a bag that's left over on the inside that's holding all of the juices, all the liquids, all the waste that you need to dispose of. So you literally take the bag out and you just tie it into a knot and you throw it away. So there's no washing, there's no cleanup really if you handle it the proper way. So these are kind of what that Millipore Mobius disposable mixing tanks are kind of like. Not necessarily, but it gives you an idea of the inside or the thought process that goes on with these big, huge tanks that no one wants to clean. Here are some pictures of different types of tanks that you'll see out in the manufacturing world. So the one to the left is the closed tank, and as you can tell, it is closed. Absolutely, it's closed. I see a lid up on the top, and that lid I do not have access to. It is completely contained. So that closed system I cannot have access to quite easily, at least. Next one is the open one, and the open one is what I called the stock pot. So this is just a big old vat, and there is a lid on top that I can open up, and I can have access to that material very easily. And this could be maybe stirring something or holding something or whatever the case is. It is by definition some type of tank, but it's an open tank that employees will have access to for the material on the inside. Next up are the conical ones, and the conical ones, of course, are a big kind of holding pot up here at the top, and then this cones down like a filter almost, and then it allows you to dispose of things maybe a little bit easier on the other side. So that is just a conical form of some type of tank that we might see on the manufacturing line. Next up are the pressurized systems, and if you look up here at the top, oh my gosh, there's all kinds of safety mechanisms up there. These containers have to be held together. They do generate a lot of pressure, and a lot of pressure will build up, and it could go boom, and I don't really want that to happen. So because of that, we've got to handle these with care. There's some extra steps that we've got to take to make sure that I am not working with a pressurized tank that's going to be like a little strolling bomb that I am pushing from one area to the next. So pressurized tanks, we're going to have to handle those with care, and we'll talk about how to do that as well. Here's the Millipore disposable mixing tanks. This is kind of what they look like, and again, all of the material will go on the inside, and then this thing can stir. It stirs basically based off of magnets or some type of propeller system that something on the outside will actually allow it to stir a little bit better for you, but that's kind of how they are made and how they're assembled. So once these get used up, these are disposable. They are one shot, and then bam, they are done, they are over, and we don't really need them for anything else anymore. So again, no one wants to clean these things. Could you imagine cleaning some of these things? I mean, they're bigger than me, right? So I'm going to have to crawl on the inside of them. I'm going to have to get dirty. I'm going to have to get filthy and sweaty, and then, you know, making sure that it is completely clean. So that's going to be some testing that's going to happen on top of that. I mean, it is an issue, and some people just don't want to deal with it at all. So in the next video, what we'll talk about are the specific pieces and parts that will be located on some of these systems or some of these tanks, and we're going to talk about some of those common parts. So we're going to define these terms, we're going to talk about what they mean, what their purpose is, and we'll go through a little checklist of them. These terms are going to be pretty important, so you better have a piece of paper and a pencil ready, because when we come back, we'll be taking quite a few notes on different terms. It's going to be important, and I guarantee you that these terms are going to show up a little bit later on online quizzes and for the Module 5 test. So we want to be prepared for those. I'm warning you now. So if you don't have one, please, 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 please get one, and that way you'll be ready when you hit play on the next video. I'll see you next time. Bye-bye.